are continuing on with homework number 12, and here's problem 2. So we have a test capacity of a welded pin. I'm not sure if that's right. A U-Hart student who weighs 180 pounds. Let me fix that. Is test the capacity of a pinned connection. A U-Hart student who weighs 180 pounds is standing on a 500-pound beam. That's kind of a big beam. Is pulling with 65 pounds of tension on a cable attached through 2 pulleys to the beam. The dimensions are 2.5 feet right here, okay, 8 feet, and then also 2.5 feet right there. He is standing 5 feet from the edge here, and he is the center right here is at we could call that BD is going to be 2.5 feet this way right here. So we want to find the reactions at pin O and roller A, and we need a correctly drawn free body diagram as part of this. Okay, so let's start it off. This is page 3 for me. And spring 2021, ES110, homework 12. Problem 2. I made that 1 into it too. All right, so let me draw this guy over here. Move my thing a little bit. So I'm not going to make him fancy schmancy or nothing. Fancy schmancy. So we get a pin here. Get a ball. Whoops. Not here. I'll extend my ground. And he is standing right here. And he's pulling this cable. And I didn't draw it very accurately. Pulling the cable. Cable comes down. Comes around. Connected right there. Here it is connected to the ground. Like that right there. We have our CD in between there and there, because this is D, this is C. We call him B. This distance right here is XBD. I'm going to move up my B a little bit so I can get my dimension. It's going to be my YBD, I guess I decided to call it. This is A, so this dimension, and this is O. So we also have dimensions X, AC, X, OA, OA. See, my thought process is I usually go alphabetical order except when there's an O. Then I go O. It's like it's the origin first when I decide, but it really don't matter. So my given, I have the weight of the student. I'll call it WB, 180 pounds. The weight of the beam, which we could call, I don't know, OD. See, O to D, whatever. 500 pounds, which seems like a lot. Force of the tension, 65 pounds right here. And we have X, OA. Did we did that one first? Yeah, 2.5 feet. What about next? AC, yeah. 8 feet. XCD, 2.5 feet. XBD, 5 feet. And YBD, 2.5 feet. Okay? And the find, we want the reaction at O and the reaction at A. Gotcha. Okay. Well, there's a couple of interesting things taking place here when trying to decide what to include or exclude in the FBD. So I would suspect that many students will try and attempt to remove the student from the FBD, but it's not necessary. You could, but you'd make it more complicated than it needs to be. So it's actually best to include the student into the thing. Keep him, looks like a him, so I think it's a him, in there. But cut the cable there and cut the cable there. Now what we're going to left with is we have him. He's got his weight coming down. And then we also have the beam, which I'll try to go halfway in between. The beam coming down. So we have A, it's reaction at A. And now we have a reaction at O, which I'm predicting is going down. So let me say FBD. Use my X and my Y. And you go, well, is there going to be any reaction at O in the X direction? And the answer is, well, look at this. Look, doesn't look like it. You'd say, well, he's going to be pulling on this right here, but it's internal to the cable is right here at this point is internal to the thing. So what would balance out that? Well, if you were to cut this, you would also be lifting his arms off thing. The friction of his feet would be the thing that would be counteracting that X component of the cable. Interesting, huh? I know. But still, gravity is still working down on him. So we have. I guess I'll put in numbers onto this instead of symbols. Yeah, maybe I'll put in symbols. FT, weight of B, weight of OD, RA, I guess I'll call it RAY, but it's the entirety, right? So that's everything. We need some dimensions in here. I don't know, almost kind of feel like I should be putting in the values that I know for this instead, because I'm about to put values in instead of variables. So I wrote down variables, but I'll stick here. 65 pounds, 65 pounds. His weight is 180 pounds. This is 500 pounds. This dimension right here is 2.5 feet. Is that right? 2.5 feet. They gave us the dimension to him. This is actually the dimension over to this dude, not to. So this XBD. So that XBD right here. I guess I'll write it in between there. We were given that was going to be 5 feet. So this is another 2.5 feet right there, right? And then we were given, let's see, the total length of this thing is going to be 2.5 2.58 and 2.5, so it's 13. It's 13 feet. I have to use a calculator for this. 13 divided by 2, 6.5. I would have got that wrong. So this is and so this is 5. So this is 1.5 right here. 1.5 feet. That's coming over to there. And so this right here is 2.5 feet. So to get to the center of this whole thing right there, right, is 6.5 minus 2.5. So that should be 4, right? So this should be 4 feet right in there. All right. So some of the moments. Let's take it. Let's figure it out about A. Let's figure out A first. So let's take it about O. Could have done the other way around. Didn't matter, right? So we have. Let's see. I probably should start over here because we have. It's going to be a long string. There's a lot of things right there. So I'll say 65 times 13 feet, right? We said it was 13 feet all the way there. Okay, sure. Plus another 65 times, now it's 6. It's going to be 13 minus 2.5, or 10.5. And then we're going to have 180 right here, and 180, and so that's going to be should be 13 minus 4, right? Should be 9. Or 2.5, no, 8. Well, let me double check that. Okay. No, he's 5 feet. Yeah, 5 feet. It says 13. So yeah, it should be 8. And then 500 times 6.5, right? Minus RAY 2.5. So RAY is going to be 65, 13, 65, 10.5, 180, 8, 500, 6.5, boom, divided by 2.5. So we're going to be 2,487 pounds. That's what I'm saying happens right there. And then the sum of the forces in the y direction, we have, so we say 2 times, it's going to be negative, 2 times 65, coming down, minus 180, minus 500, plus 2,487, and I'm saying this is going down, so it's going to be minus Roy. And so I'm going to say that Roy right here is going to be, we're going to subtract out all these things, right? Just subtract out 500 from there, 180 from there, 65 times 2 from there, and I'm left with that this is going to be 1,677 pounds. So my answers are going to be the reaction at A is equal to 2,487 pounds upwards. Reaction at O is 1,677 pounds downwards. And I think I got it right. I don't know. All right, so let us be done with our 14-minute video.